Welcome to the Copperfield Electric Podcast. You know, I was looking at my apartment the other day, just staring at a pile of laundry, and I had that fantasy, you know the one,
Oh, I know the one.
the tiny home fantasy. I sell everything, buy a plot of land, move into this, pristine 200 square foot architectural marvel.
No clutter, just simple living.
Exactly. But while I was scrolling through these endless videos of van life and backyard cottages, I realized something. They always show you the clever storage stairs,
And the fold-down table, yeah.
but they never show you the walls. Or, I mean, what's inside the wall.
Because insulation and copper wiring aren't exactly Instagram-worthy.
Right. But that's the lifeblood of the house. And it got me thinking, how do you actually wire a place that's the size of a master bathroom? Do you just, run a glorified extension cord out the window?
That is the million-dollar question, or maybe the $50,000 question, depending on your budget. It's a huge logistical puzzle that most people don't even consider.
So that's our mission for this deep dive. We're looking at the intersection of, let's say, regular construction materials and these irregular tiny living spaces. Can you actually wire a tiny home with stuff from a standard hardware store?
Or are you stuck ordering some niche NASA-grade micro equipment? It's a fascinating engineering challenge, really. You're compressing the infrastructure of a standard American home into a shoebox without, starting a fire.
And we aren't just guessing here. To navigate this, we're pulling from a bunch of research, but our main guide today is the expertise of Copperfield Electric.
Which is a name that probably rings a bell if you're in Southern California.
Right. They're a family-owned business serving Orange County and the broader area. And what's interesting using them as our lens is their credentials. This isn't just a guy with a truck and some tools.
No, this is a team of highly trained, licensed, bonded, and insured electricians.
And the key thing here, especially when we talk about your house, is availability. They bill themselves as a 24-hour electrician.
Which is huge.
It is, because things never break at 10 in the morning on a Tuesday. The breaker always blows 5 minutes before the big game starts.
It is Murphy's Law of Voltage. Having a team on call 24/7 for emergencies, it completely changes the game for a homeowner. You're not left in the dark wondering if your house is safe.
So we're going to take their professional standards and apply them to this tiny home problem. We want to find those aha moments, how to keep the lights on safely and efficiently. But before we get into the wire nuts and bolts, let's ground this. When we say Copperfield serves the area, where are we talking about?
It's a pretty big footprint in Orange County. So you've got Irvine, Anaheim, Santa Ana. That's kind of their central hub.
Okay.
But they also cover the whole coastal stretch. Costa Mesa, Newport Beach, all the way down to Laguna Beach.
So they're seeing everything from suburban homes to high-end coastal properties.
Yeah.
Looking at their About Us page, I was kind of surprised by the scope of what they do. I just think of electricians as, the people you call when a light switch stops working.
That's the old break-fix model, yeah.
Yeah.
But modern electrical work is much broader. Copperfield, for instance, lists installation for new construction. And this is where it gets really relevant to our topic.
Let me guess.
They explicitly mention ADUs.
ADU, accessory dwelling unit.
Correct. Which is the legal term for what most of us call a granny flat or a backyard cottage. Basically, a tiny home on a foundation.
Got it.
So they handle that, but also EV charger installations, which is huge right now.
Yeah. Panel
upgrades, lighting, all of it.
There was one phrase in their company values that really stood out to me. They call themselves honest electricians.
Which sort of implies that there are dishonest ones out there.
Well, yeah, it's a common fear, right? You call a pro, they look at your panel, suck their teeth, and tell you that you need a $5,000 upgrade when maybe you just need a new breaker.
Right.
Copperfield's whole philosophy seems to be, we only diagnose a problem if there's actually a problem.
That is so crucial. Troubleshooting shouldn't be a sales pitch. It should be an investigation. You want a detective, not a salesman.
Okay, so we have our experts, we have our context. Let's go back to my tiny home fantasy. I have bought the frame. I'm putting up the walls. I walk into a big box hardware store.
Yeah.
Can I just grab the standard yellow Romex wire and standard outlets?
The short answer is
yes.
yes. No asterisk.
Well, there's always an asterisk in electrical engineering. But fundamentally, yeah, you can use standard 120 volt and 240 volt components, standard breaker boxes, outlets, switches, the whole thing.
That seems almost too easy. I just assume since the house is small, the gear had to be small, like RV parts or something.
You could use RV parts, but residential gear is often safer and cheaper. The electricity doesn't know how big the house is. 120 volts is 120 volts. But this is where that special attention clause comes in.
Here's the asterisk.
Here it is. Just because you can use standard parts doesn't mean you install them the standard way.
Okay, give me an example. What goes wrong if I just install an outlet like I would in my living room?
Think about box fill.
Box fill, what's that? It's a code term. That blue plastic box in your wall that holds the outlet. It has a specific volume. In a normal house with 2x6 walls, you have plenty of room. Tiny homes often use 2x4 framing to save space.
So the box itself is too deep for the wall.
Exactly. Or, and this is worse, you try to cram too many wires into that small box. Wires create heat. If you violate the box fill calculation by stuffing too much copper in there, you get heat buildup.
And heat inside a wall is very bad.
Heat is the enemy. It melts the insulation, you get arcing, and potentially a fire. So while the outlet is standard, you have to select compact boxes or shallow depth devices that fit. It's like playing Tetris, but if you lose, the house catches fire.
Wow, that's a high-stakes game of Tetris? Okay, let's talk about power load. In my fantasy tiny home, I still want a microwave and a hairdryer.
Of course. You don't want to live like a pioneer.
No. So this is the second major hurdle, circuit design. In a big house, you might have 40 circuits. In a tiny home, you have limited panel space.
And the temptation is to just put everything on one breaker.
Right. It's just one room, one circuit. Seems fine.
But let's do the math. A standard circuit is 15 or 20 amps. A microwave pulls about 1,500 watts. A hairdryer, about the same.
I remember enough high school physics to know watts divided by volts equals amps.
You got it. So 1,500 watts at 120 volts is roughly 12.5 amps. If you run the microwave and the hairdryer at the same time,
That's 25 amps?
and pop goes the breaker. Instantly.
So you're overloading the circuit.
Immediately. Even though the house is tiny, the electrical draw isn't. You have to plan for those high-power devices just like you would in a mansion. You can't cheat the math.
Okay, so I've got my shallow boxes. I've planned my circuits. But where's the power coming from? If I'm parked in a backyard in Santa Ana, am I just plugging into the house?
This is where it branches out.
Yeah.
Research shows 3 main scenarios. Scenario 1 is grid electricity.
The standard setup, right.
Most common for ADUs, like the ones Copperfield wires. You're hardwired into the city supply, usually through a subpanel from the main house. It's reliable, unlimited power.
Okay, scenario 2.
Solar panels. The off-grid dream. You generate your own power, stored in batteries.
Does that change the wiring inside the walls?
The copper stays the same, but voltage management becomes the critical piece. This is where you get scenario 3, the hybrid model. See, whether power comes from the sun or the street, your outlets need to deliver 120 volts AC.
Because my TV doesn't run on raw solar power.
Exactly. Solar panels produce DC, direct current. Your home runs on AC, alternating current. You need an inverter to make that switch.
And I'm guessing not just any inverter.
Not at all. A cheap inverter produces what's called a modified sine wave. It's a choppy, blocky signal. Your sensitive electronics, your laptop, your smart devices, they hate it. They can overheat or just fail. You need a pure sine wave inverter to replicate grid power.
This is starting to sound like something I definitely should not be doing after watching one 5-minute YouTube video.
It is absolutely not. Integrating inverters and battery banks is complex. This is where professional installation is vital. You mess up the grounding on an inverter, and you can electrify the entire metal chassis of your tiny home.
That is a terrifying thought. Speaking of things I saw on YouTube, I have to ask about the extension cord.
Oh, no.
I saw a video where a guy just ran a thick orange cord from his parents' garage, buried it under some mulch, and called it a day.
I need you to promise me and everyone listening that you will never, ever do that.
I mean, it looks so convenient.
Convenience is the enemy of safety. Extension cords are for temporary use. They're not insulated to be buried. They're not rated for that kind of constant load.
But does the power even get there?
Barely. You get something called voltage drop. Wires have resistance. The longer the wire, the more resistance. By the time the electricity gets 100 feet to the shed, you might only have 105 volts instead of 120.
So my heater just runs a bit cooler.
Or the motor in your fridge burns out because it's straining on low voltage. That voltage drop turns into heat in the cord. So you're melting the cord, starving your appliances, and creating a massive fire hazard. It has to be hardwired properly.
Loud and clear, no buried orange cords. Let's switch to something that seems to be a unanimous recommendation. Lighting. Why is everyone so obsessed with LEDs in tiny homes?
It all comes down to the energy budget. In a normal house, if you leave a 60-watt incandescent bulb on, who cares? In a tiny home on solar, That 60 watts is a huge chunk of your available power.
It's like leaving the faucet running when you only have a small water tank.
That's a perfect analogy. LED's light-emitting diodes use a fraction of the power. We're talking maybe 7 or 8 watts for the same amount of light as that 60-watt bulb.
And Copperfield Electric mentions this isn't just a tiny home thing, right?
No, it's universal now. They note that LEDs are the top choice for homes and businesses everywhere. They're more efficient, they last practically forever, and they run cool.
That run cool part seems important for a small space.
It is. In a tiny loft where you sleep, you don't want a light fixture radiating heat like a mini oven inches from your face. Plus, the fixtures can be flatter, more streamlined. You save headroom and you save amps.
It's a total win-win. Saves money for a business in Costa Mesa, saves battery life for a tiny homeowner in Laguna Beach.
Precisely. It's all about load management.
Okay, let's get into the danger zone. What are the absolute don'ts? The things that make an inspector or a Copperfield electrician just cringe?
Number 1 is overloading circuits, which we talked about. But a close second is skipping code requirements.
The temptation is to think, it's just a shed, the rules don't really apply.
And that is a dangerous mindset. The code exists for safety. Take GFCI outlets, for example.
The ones with the little test and reset buttons?
Yes, they're required anywhere near water. In a tiny home, everything is near water. The kitchen sink might be 3 feet from your bed. If you skip GFCIs, you're removing a critical safety layer that prevents electrocution.
What about placement? I imagine where you put the outlet matters a lot more.
A huge mistake people make. They wire everything up, then realize they put the only outlet right where the Murphy bed folds down. Or they put a light switch behind the sliding barn door. You have to literally walk through your day in your mind before you run a single wire. I walk in, I reach here for a switch, I sit at my desk, where's the plug?
And any last don't for the solar folks?
Failing to monitor your system, solar output changes, clouds happen. If you're running a heater and not watching your battery levels, you can drain the system flat, which damages the batteries permanently. It requires active management.
You know, listening to all this, it sounds like a lot. I feel like if I tried to DIY this, I'd just end up sitting in the dark with a burnt-out inverter.
It is a lot. Electrical work has a very steep learning curve, and the penalty for failure is high.
Which brings us back to the professional route. If I'm in Irvine or Newport building an ADU, I don't have to keep all these code requirements in my head.
You absolutely shouldn't. That's what the team at Copperfield Electric is for. Their website has a line I really liked. If you are concerned about a failure or malfunction, then we need to come diagnose and troubleshoot.
It's a preventative mindset again. Let us fix it so you can focus on what you need to do.
And what you need to do is live your life, not worry about the wire gauge in your wall.
So let's wrap this up. If I'm dreaming of that tiny home or just trying to keep my regular home safe, what's the takeaway?
The takeaway is that wiring a home, any size home, is an exercise in precision. Yes, you can use regular materials, but you need a rigorous plan. You have to calculate your loads, respect the physical space, and adhere to safety codes as if your life depends on it, because it does.
And if you are in Southern California, specifically Orange County, from Tustin out to the coast, and you need a partner for that, you have a resource.
Copperfield Electric. Whether it's wiring that new ADU, installing an EV charger, or just handling a midnight power outage, they're that 24-hour resource.
For anyone listening who wants a professional opinion, their number is 626-622-9694. That's 626-622-9694. And their main office is right in Tustin at 1581 Copperfield Drive.
Reliable, local, honest. That's really the trifecta you want.
Before we sign off, I want to leave the listener with something to chew on. You had a thought earlier about how all this tiny home talk applies to, well, the rest of us.
Yeah, it's this idea of efficiency versus availability. In a tiny home, you are forced to be efficient. You're hyper-aware of every single watt because your supply is limited. You turn off lights because you have to.
Whereas in my house, I leave the TV on for the cat and run the AC with a window open.
Exactly. In a standard home, we treat electricity like it's an infinite resource. We just assume the grid will always be there. We only think about it when the power goes out.
Yeah.
But maybe that meticulous planning from a tiny home is a mindset we should all adopt.
What do you mean?
If we treated our 2,000 square foot homes with the same respect for load management and efficiency as a 200 square foot one, we'd save money, we'd strain the grid less, and our homes would just be inherently safer.
That's a really powerful perspective. Stop treating electricity like magic and start treating it like the resource it is.
It definitely changes how you look at a light switch.
It really does. Well, that's all the time we have for this deep dive. Thank you for joining us.
Stay safe and keep the lights on.
We'll see you next time.